Hi, we are from Group 11 and we are proposing Smart Forest Fire Detection System. This is the architecture diagram and it consists of a few AWS services such as S3, LT Core, EC2, Amazon Recognition, Lambda, SNS, then DB, Amazon Antenna, and also QuickSight. And the solution that we are proposing is we will install sensors and cameras in the key location of the forest, and the devices will capture the data at regular interval. And when fires is detected in the sensor data or images, the authorities will be notified in real time. Lastly, we will also illustrate those data with graph and diagram. And I will talk about the sensor data. These 5 services is needed to perform the sensor data. And I will perform a quick demo on EC2. Firstly, in the Amazon Management Console, you can give any name to the instance. Then you should select the free tier eligible Amazon machine images and also architecture. And then for instance type, you also select the free tier eligible. And for key pair, you need to create a key pair and enter any name for the key pair. And the key pair type is RSA and the format is PPK. After you create the network settings, you can leave as default setting. And this one, configure storage also default setting. And after you check on the summary, you can launch the instance and you will see the instance is created. And these are the details of the instance. Then for IoT core, you need to create a thing. Then you need to give a name for the thing, and the default device shadow you can leave it as default, and as well as for this one as by default. And the policy, you need to create a policy and give a name for the policy. And for the policy, you need to allow the 4 policy, which is connect, publish, receive, and subscribe. And after you created, and you need to select the policy and create the thing. And after you have created the thing, you should see this. Then I will show the connection between EC2 and LT core. And there are 5 steps to perform this. And firstly, you need to prepare a device. So you need to copy the ping command and open up your EC2 and paste it there. If it is successful ping, it will show something like this. And then go back to the steps just now. Should choose an existing item which you created just now and click next. And for the platform and SDK, you should choose Linux and also Python. And after you click next, you should see this and you should click on the download connection kit, and a zip file will be downloaded in your PC. And then in order to transfer file from your PC to the EC2, you can install some software like WinSCP, and you should enter those details like this. And then you should click on the advanced and click on the SSH authentication and select the key pair that you created just now. Click OK. And after that, you should drag the zip file from the left to the right. Right is the file location in your EC2. And then go back to the step just now. Copy the unzip command and paste it in the terminal. And this will unzip the file. And then copy both of this command and run on the terminal. After that, you should see this result which indicate that the connection is successful between EC2 and also LT core. Okay, then you also see this. Next, I will show you how to set up the DB. You should go to the DB and create a table and give a name for a table. Partition key will be device ID, which is number type, and sort key will be, in our case, the sort key should be timestamp. And then the table settings can set as default setting and create table. And then you should see this table is created. Okay, then I will show the connection between LD core and DynamoDB. There are 4 steps. First, you need to create a rule. And create a rule, you need to give a rule name and then click next. And for the SQL state version, you should select this, and the statement you should write like this. And then after that, for the rule action, you should select the DynamoDB, and the table name is the table that I created just now, and also fill in the details of the table. And then after this, you should click create. You should create a new row and then give a row name and click create. After you will review and confirm, and you should the connection between LD core and the DynamoDB is successful. And now I'll show you how to set up Lambda. So for Lambda, you can create a function and select author from scratch and give a function name and select Python 3.10 and click create function. After that, you should see something like this without the DynamoDB. And then you should click on add trigger and you will come to this page. Select DynamoDB, select the table that I created just now, and then click add. And then scroll to the bottom. You should paste your code at there and click on deploy. And basically the code that I want to highlight here is we do some if else statement to check whether the sensor data exceeds certain limit. If yes, it will notify the authorities. Okay, then now I'll show you how to configure the SNS. Okay, so for SNS, you can click on the create topic and then select the standard and give a name, and then you create the topic. Next, you should also create a subscription, and the topic you should select the topic that you created just now, and protocol you can select email, and the endpoint you should enter the email that you want to receive, and click create subscription. And then after that, you should receive a email to confirm the subscription. After that, I will show you how to publish the data from LD core to the DynamoDB. Okay, so you go to the LD core and select MQTT test client, and you should enter a topic filter for the subscription, and then the name of the topic filter you can view from the SQL statement just now, which is device plus data, and create subscribe. And you should see the subscription below, and that's in the publish to a topic tab. You should enter the topic name. You should replace the plus with 1, and this is the message payload that you should enter, and then publish. After you click publish, you should see something like this below. And after you publish, you can go to the DynamoDB and the records will be inserted here. And besides that, you also receive an email because we have connected with the Lambda, and the Lambda will perform this. Thank you.
My name is Vijayajun, and I'll be demoing for S3 to Lambda, and also Lambda to recognition and Lambda to SNS. So firstly, we'll go to IAM and then go to roles and create a role. So for the use case, we'll put it as Lambda, and then for the permission policies, we'll add S3 full access, and then CloudWatch full access. And lastly is recognition full access. Then after that, we'll press the next button and then give it a role name. So I'll put it as LN role, and then I'll create a role. Then it will show the role is created. Then we'll go to SNS and then go to topics and create a topic. For the type of the topic, we'll put it as standard, and then for the name, we'll put it as SNS Forest Fire. Then we'll create a topic. Then after that, we'll create a subscription, So for the protocol, we'll put it as email, and then we'll put our email address, and then create a subscription. So for now, an email address will be sent to the email that you entered. So you can go to our email address and then confirm the subscription. So after that, you will see that status is being confirmed. Then we'll go to Amazon S3, and then in the buckets, we'll create a bucket. So we'll give it a name as bucket forest fire. Then make sure the AWS region is the same, and then we'll create a bucket. And then it will show us that the bucket is successfully created. Then we'll go to AWS Lambda, and then go to create function, and then we'll use a blueprint, and the blueprint name we will use recognition. So use recognition to detect faces. And then for the function name, we'll put it as recognition forest fire. And for the execution role, we'll put the existing role which we created, which is the IAM role. And then we'll remove this for now, and then create the function. Then we successfully created the function. And now we'll add a trigger. And then for source, we'll put as S3. And then for the bucket, we'll choose the bucket that we created, which is bucket forest fire. And then we'll take the recursive invocation and add the bucket as the trigger. And here we successfully added the bucket as a trigger. So after that, we'll go to code, and then we'll change the code to this. So we'll import the things that we need, and then we'll call the recognition API and also SNS API. And the recognition will detect the S3 bucket which contains our image. And then if the image has been recognized as forest fire, it will send a message from SNS to our email address with the title uploaded image labels. And then we'll deploy the code. And then it will show us that we have successfully updated the function. So in order to know if the code is working, we'll go to S3, and then we'll select the bucket that we created, which is bucket forest fire, and then upload a picture. So we'll upload a forest fire picture, and then upload. And we should be receiving an email from that is sent by SNS. So here you can see that the email is sent by SNS, which contains the info of the image. So the fire is 99.8%, and the forest fire is 99.8% as well.
My name is Hodeling, and I'll be explaining on how we visualize our data from DynamoDB in Amazon QuickSight. For Amazon Athena, it is used for real-time analysis on the sensor data and helping to identify patterns, trends, and anomalies that indicate potential forest fires risks. While Amazon QuickSight is used to create interactive visualizations and dashboards to represent the sensor data. This will help to monitor the forest conditions, identify trends, and also detect early warning signs for potential fires. This is the QuickSight part for the architecture diagram where the data from DynamoDB is read by Amazon Athena through DynamoDB connector after the DynamoDB store sensor data collected from IoT devices deployed across the forest such as temperature, humidity, and smoke levels. Instead of using AWS data pipeline or AWS Glue, we are directly spilling the data into Amazon S3 buckets. First, let's look at our data. As you can see, we have device ID, timestamp, and some simple sensor data, such as temperature, humidity, and presence of smoke. We want to record down the timestamp because we want to know when the camera captured our fire instances. Here we prepare S3 spill data and result data bucket for Amazon Athena. This is the DynamoDB connector. The primary purpose of the DynamoDB connector is to simplify the process of analyzing and processing data from DynamoDB. Now we have created our data source. We will try to read the table in sensor data table 1 by running the SQL query. We select run, then we are able to view the data. Then we want to visualize data in Amazon QuickSight. We need to click on the new data set and create new Athena data source. In the next step, we select the table that we want to visualize. Visualization is used so that we are able to detect the possible fire occurrence when the temperature level is at the highest, low humidity, and smoke is present. And also used for identifying values for highest and lowest sensor data. That's all from me. Thank you.